Our objective for today, I can simplify exponential expressions using multiplication properties of exponents. Read together. 1, 2, 3. I can simplify exponential expressions using multiplication properties of exponents. So today, like I said, we're revisiting exponents. We already covered that at the beginning of the year. But today I want to make sure that you understand the property that we're looking at. Okay? So, did I just say queso? Okay. So. All right. So, you got your objective written down, right? If not, it's on the board. So in the Freire model, our concept for today is exponential expressions. What are they? So let's see. I'll give you guys some time to copy that. So what is an exponential expression? Let's see. Exponential expressions are a numerical or variable expression raised to a power greater than 1. Numerical or variable expression raised to a power greater than 1. Copy that, please. A numerical or variable expression raised to a power greater than 1. Examples. 2 cubed, x to the 6th, negative 3x to the 4th, x squared, y cubed. Copy that, please. Now I'll go over it with the definition. All right. So, let me go over this. According to the definition, check this out. Look up to the screen. It says, a numerical or variable expression. Numerical or variable expression. De acuerdo a la definición, expresiones de exponentes tienen expresiones numéricas y variables. So let's see. This is only a number, therefore it's a numerical expression. Are we there? This one has a number and a variable, so this is a variable expression. Variable expression, variable expression. Yes? And it says that they have a power greater than 1. 3, 4, 6, and so on and so forth. You guys see that? Okay. And they are expressions. Okay. So, let me show you what it is not an exponential expression. Look at this one. Right away, you should notice something, that these are not exponential expressions. So copy that. As you're copying it, start thinking in your head, these are not exponential expressions because, and then start answering your question. And then let me give you one more non-example. Copy this one also. Negative 3 plus x. All right. Take a little bit and talk it over with your neighbors. Why are these exponential expressions and why are these not exponential expressions? Let them know, please. Go. Okay, here we go. Help me out with these two first. Manny, why are these not exponential expressions? They have an equal sign. So what are these called if they have an equal sign? Equations. Thank you, Manny. Equations. So what do you guys notice about these? These don't have equal signs. That's why they're not equations. They are what? Expressions. Are we there so far? All right. How about this one? Why is this not an exponential expression? Pass to someone, Manny. Maddie, why is this not an exponential expression? It doesn't have an exponent. Does everybody see that? So what's so important about exponential expressions? That they need to be what? Have an exponent, and they have to be what? Expressions. So write that in here. Expressions only, and exponents greater than 1. Copy that. Okay? So, we need steps. Here we go. Write these down. There's only 3 steps. For step 1, I only want you to write identify the exponential expression. Hold on. Identify. No, go ahead and write it out. I was trying to shorten the step. But it says, identify if the exponential expression is a product of powers, power of power, or power of products. We're going to be looking at 3 properties. Step 2, use the appropriate property to compute. And at the end, simplify. Copy that, please. Hand says, need more time? Okay, we're good? All right. So here we go. We got our steps, and just let me give you a couple of notes to keep in mind as we go through this lesson. Look up, please. Whenever you see a number that does not have an exponent, it does have an exponent. It's invisible. The exponent is a 1. If you see a variable that does not have an exponent, it does have an exponent. It also is 1, and it works also with negative numbers. Okay? So, from there, the other 2 properties that we're going to be using are these 2, commutative property of multiplication and associative property of multiplication. Now, what does this mean? It means the following. Look up, please. You've used these before, but maybe you didn't understand them. Here it goes. If I give you 3 numbers, 2 times 3 times 5, the product of 2 times 3 times 5, that is 2 times 3, that's 6, times 5, that's 30. Commutative property says if you change the order of the numbers, the product is the same. Here it goes. Once again, if I change the order, so watch. I'm going to change this to 5 times 2 times 3. So what is 5 times 2? 10 times 3? 30. Is it the same as this one? Yes. So the order doesn't matter. That's why they call it commutative. Commutative comes from the word commute. Commute means to travel. Who's heard that word before? Commute means to travel. So guess what? Look at this one. If this is the original order, look at this one now. Which number traveled? The 5. It went from the back. They brought it to the front. That's why this property is called commutative, because you can move numbers around. They travel. Does that make sense? All right. That's commutative property. Associative property is kind of like when you have friends. Some of you hang out with 2 other people, right? And sometimes you get mad at one person, and you're like, oh, let's not talk to them. And guess what? You start only talking to one person. But eventually, you guys get upset, and then what happens? Then you start talking to the other person instead. Associated property means it doesn't matter how you associate the numbers, the product is the same. Watch. What is 2 times 3? 6 times 5? 30. What is 5 times 3? Times 2? 30. It's still the same. Those are the two properties that we're going to be using. Are we there? No? We guys okay? All right. You guys don't have friends like that, right? That you don't want to talk to? All right. Let's move on. So, write on your paper, product of powers property. Product of powers property. Here we go. Example Q. I want you to write 2 times 2. Underneath that, we're going to write 2 times 2 to the third. Underneath that, we're going to write 2 to the third times 2 to the fifth. But since now we've been working with algebra, now let's do it in algebraic terms. X times x, x times x to the third, and x cubed times x to the fifth. Okay? So, when we started today's lesson, we did the warm-up, and now we know the parts of the exponential expressions, right? So when we start talking with each other with this lesson, I want you to use those terms that we used, base and exponent. You guys remember that, right? All right, here we go. Pens down, eyes up here. Let me show you the property. This property is called the product of powers property. I'm going to show it to you. I'm not going to say anything, and you need to start thinking of a definition. Think about the rule and the definition. Everybody understand? So I need you guys to pay attention. Here it goes. I'm not going to say anything. Just pay attention. Don't say it out loud. Copy that. As you're copying that, start thinking. My definition for this rule is if I blah, 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 then this. You already have your rule in here, right? Copy that. I'll give you some time. All right, let's see. We're going to write our definition. Here we go. Put a asterisk and a heart. Aww. So we can remember the definition. Here we go. So, this property is called the product of powers property. Product means, or what does it convey? Product means what? Product is what? Multiplication. Okay. So let's start our definition. When what? When multiplying. What are we multiplying? What are these called? What was the lesson called? Exponential expressions. When multiplying exponential expressions, let's see, we're multiplying them. Okay. Let's see, who can give me the rule? What do I write from there? Yes?
Add the exponent if the base is the same.
Let's start with the last part first. If If the bases are the same, then add the exponents. Period. And then 10Q. So let's see if it makes sense. When multiplying exponential expressions, are we multiplying here exponential expressions? Yes. If the bases are the same, are the bases the same? Yes. What happened to the exponents? We add the exponents. Did that work? Yes. All right. So, now that we have the hang of this property, let's put it to practice. Here we go. Example, super Q. Copy this down, please. 2 cubed times x to the 5th times 2 times x to the 18th. Let's do this one together. Let's do this one together. Okay, my bad. Let's do this one together, please. Here we go. Look up. And let me show you why we're going to do this one together, because I want you to do this step by step. Here he goes. First of all, notice that these, look up, we were able to do this because they had the same base and they were next to each other. Is that correct? Yes. Are these next to each other? No. So for the first thing is to reorganize it. Is that correct? Yes. So what am I going to write? 2 cubed times 2 times x to the 5th times x to the 18th. That is correct. That's the next step. Now, how come we were able to do that? What property did we use? Think about it. What was the property, everyone? So write it right next to here. Commutative property. You can just abbreviate so that you know what property we used. Okay? Now that we have them like this, don't forget to put the little exponent of 1 here on this 2. And now I'm going to group them. Watch. These 2 together and these 2 together. What is it called when I group them like this? Everyone. Associative property. That's why we are able to do that. So now let's simplify it. What is 2 to the 3rd times 2 to the 1st? 2 to the 4th. Times x to the 5th times x to the 18th. That's x to the 23, Michael Jordan. Now check this out. Look up, please. If I was to write simplify, this is what you would do next. Look up. This one is 2 times 2 times 2 times 2. What is 2 times 2? 4. Times 2? 8. 2 times 2 is 4, times 2 is 8, times 2 is 16, and bring down the x to the 23rd, and we're done now. Copy that, please. Is everybody understanding what we're doing now? Okay. So, I'm going to give you one just like this and see if you can do this one by yourself. Copy this down, please. Example, mega Q. Here we go. 3 times y to the 7th times 3 to the 2nd times y to the 5th. Go ahead and simplify that. Copy that and go. All right, here we go. What'd you get for this one, please? Or actually, walk us through the steps. Anissa. What is my first step? Yes. Next to the same kind, so then it's 3 to the 1st times 3 to the second times y to the seventh times y to the fifth. Pass it to someone. Luis? Combine together, so you group them together. Okay? So before that, Anissa, what property did we use to switch them around? Commutative. And Luis, what property did we use to group them? So what do we end up here? To the third. And times 12. Pass it to someone. And to simplify, what do I do? Pass it to someone. Reniel, what do I do from there? Three. Okay, and what is that? 27, and you bring down the y12, and we're done. Hands if you got that. That is correct. Let's do another one. Here we go. We got this? Okay, here goes a challenge one. Here we go. See how you do with this one. Example, Power Rangers Q. Bam. Here we go. 2 times x to the second times y to the seventh times 3 times x times 2 to the third times y to the negative 2 times 3 times x to the negative 1. Yes, you are. Copy that. Go. Okay, let's see what we got. First things first. Rewrite this. So this becomes 2 to the first times 2 to the third. Is that correct? Times x to the second times x to the first times x to the negative 1. Yeah, this one is a 1 and this one's a negative 1. There's 3 x's. This one, and this one. Next, times y to the seventh times y to the negative 2. Next, times 3 times 3. Hands if you got up to right there. Okay, good. So far, so good. Let's group this. These together, these together, these together, and these together. These have exponents of 1. Therefore, this becomes 2 to the fourth. This becomes x, let's see, 2 plus 1, that's 3, plus negative 1, that's 2, times y to the 7 plus negative 2, that is 5, and this one is times 3 to the second. Are we there so far? And we're still not done. This is 2 times 2 times 2 times 2. Is that correct? That is 16. This one is 3 times 3. That is 9. And what operation is in between? Multiplication. So what is 16 times 9? 144. Yes, that's what simplifying means. Didn't we do that with this one? Yes. At the end, when we simplify, we need to multiply all of them together to simplify to the end. Aren't these all numbers? Yes. So write that down if you didn't write it down. So we're done with the numbers. And what's left? We write down x squared, y to the fifth, and we're done. Who got up to right there except for the last multiplication? Okay, that's good. At least we got all the way to the, so now you know what to do at the end, right? Yeah. Okay, let's do another one. Here we go. Ready? Then, no. Here we go. Example, Shazam Q. Shazam. Here we go. 5 times A times 2 to the second times B to the third times A to the negative 7 times 5 times B to the negative 1 times A to the 6. That's it. No, that's good. Copy that and simplify. Go. Okay, fine. There it is. This is B to the negative 1. I'm going to start with the first step. Here it goes. 5 to the first times 5 to the first times A to the first times A to the negative 7 times A to the 6 times 2 to the second times B to the third times B to the negative 1. So far, so good? Associative property. All right, this becomes 5 to the second times A to the 0 times 2 to the second times B to the second. And if you got it to right there. Okay? What is 5 squared? 5 times 5, that is 25. And what is this one? 2 times 2, that is 4. So what is 25 times 4? 100. Okay? Bring down A to the 0 and B to the second. Hands if you got that. Okay? Now check this out. Look what I'm going to do. The correct answer, that one I'll take that. But this is the correct answer. So, look up. What do you assume A to the 0 is? No, because if we multiply times 0, it becomes what?
0.
So therefore, it has to be what? 1. So the rule, and the rule that you need to remember is that any number to the power of 0 is 1. Any number to the power of 0 is 1. Now, a heads up for tomorrow. Today we did multiplication. Tomorrow we're doing division. Look up. 2 to the 5th divided by 2 to the 2nd. Now, question. Check this out. If today, when we multiplied, we added the exponents, so what happens now that we're dividing? So this becomes 2 to the 3rd. Bam! Home plate for tonight is on page what? 468. 468. Have a good one, guys. Enjoy your home play. See you guys tomorrow.